in the unit name today. What is that word? Yep. And what's the other one? Oh, this did not say relations. Miss Lai. This should actually say functions. That's funny. Before I start, I want to talk to you about this double meaning situation. So when I have a rectangle, what are the characteristics of a rectangle? Talk to your seat partner right now. What are 2 or 3 things that make a rectangle a rectangle? Yes. Yeah. Yeah. So you're factoring. And when you say find the solutions, you're saying that's the solution. Yeah. Don't, no wandering eyes. Come on. All right. So a rectangle. Yeah, and you gotta pull this out. I know it's a funny one. What's one thing about a rectangle? Yeah. Gorgeous. 490-degree angles. Another piece? Tell me about the length of the sides. Yeah. Okay. Yes. And tell me about the longer sides. Okay. And the shorter sides? Right? They're equal in length. Okay. Here's a question. Is a square a rectangle? Discuss. Okay. So is a square a rectangle? Who says yes it is? Who says no it's not? And who's not voting? All right. Let's try again. Everyone has to put their hand up. Who says yes a square is a rectangle? Who says no it's not? Okay, good. Everyone is. So I reworded this characteristic. A rectangle is a shape where the opposite sides are parallel and equal in length. Is a square a rectangle? So when you have a square, are the opposite sides parallel? Yes, they are, because it's all 90-degree angles. Are the opposite sides equal in length? This is the same. Well, this is the same as well. It just so happens that all the sides are the same. So folks, a square is a rectangle. Now, what's the additional characteristic for a square? All sides are equal. So is a rectangle a square? No. Good. So what we see is there's something called a rectangle. Okay, let's just put all the rectangles in the world in this bubble. Well, and in that bubble, there's a certain type of rectangle called the square. Does that make sense? So everything that's a square is also a rectangle, but not vice versa. This is going to be an idea that's going to be helpful in today's lesson when we talk about functions and relations. Okay, so let's talk about, first of all, what is a relation? So a relation is a set of ordered pairs, usually listed as x comma y. So coordinates. Where do you see coordinates? On a graph. So when you have dots on a graph, any kind of dots, it could be a line with infinite number of dots. That is a relation. A relation is like, how is the x and the y related? Okay, so can you draw this on a graph? This? Show me with your hand what it looks like on a graph. Yeah, everyone show me. We got the good old parabola. Okay, so how many points does a parabola have? An infinite number, right? It's like there's a point. There's an infinite number of points. Does every point have an x value and a y value? Yes. And so that makes it a relation. And I think of a relation as like relationship. Well, what's the relationship for y and the x? Well, watch this. The y is related to x because it is the same as the x squared. So you can't just randomly get a y or randomly get an x. I can't just be like, oh, this is part of the parabola. No, I have to actually take the x, put it in the equation and say, oh, it's actually the y is a 9. That's the relationship, and it's a relation. Now, it's a set of ordered pairs. Okay, so over here, I've got 3 relations. Okay, how many ordered pairs does the first relation have? Show me with your fingers. 4. So it's 4 points, right? So let's just take this one graph and let's put some numbers here. Let's have them go up by 1 and let's just plot all these points. So let's remember that it goes in alphabetical order. The x comes first, the y comes next. 2, 3 is up here. 4, 5. 4, 5 is up here. 6, 7. 6, 7 is here. And 8, 9. 8, and I'll have to go off script, is 9. This is relation A. If I were to connect it, what type of a relation would it be? What's the word that we would use to describe this relation? Yeah, it's a linear one, right? It's a straight line. Let's plot the second one. So relation B, we got 6, negative 2. 2, 3, 4, 5, 6. We got 6, negative 1. We got 6, 0. We got 6, 3. Also linear. Unique about this is that it makes a vertical line. And go ahead and plot relation C. So basically, a relation is just any set of points on a graph. Okay, don't worry if you didn't get all of them. We see, okay, points on a graph, the x, the y, it's related somehow. Well, we can represent those relations in a different way. One way we can show them is to say, oh, they can be points on a graph. Another way that we can show them is writing it in this notation. Do you remember this notation from grade 9? Do you remember what this curly bracket means? It means a set of. So when you make a set, this means set of. Okay, so when you have these type of curly brackets, that means, oh, this is a set. They are related. They are together. These type of brackets we use for a point. So the different kinds of brackets communicate some information to us. So the first way we're seeing a relation being expressed is in set formation, where we're just listing the points. Another way is we can plot the points, and a third way is we could write the relations as an equation. Okay, so let's connect these points to see what the equation of that line would be. Okay, so go ahead and try to figure out the equation. So we're thinking y equals mx plus b. Okay, if you're not sure, you can at least find the b. What's the y-intercept? Slope, I'm going to find 2 points. I'm going to go, okay, I go run 2, rise 2. So it's going to be 2 over 2. So my slope is 1. So I can write it as y equals 1x, or just x, plus 1. Okay, that's just the equation of the first relation. The second relation is a vertical line. Okay, do we remember how to write the equation of a vertical line? I always got confused by this one. So we have to look at which value, the x or the y, is not changing. So look at these points. Let's even look at the list. Which coordinate did not change, x or y? Say it out loud. Okay, so that means, and what is x each time? X equals, folks, that means the equation is x equals 6. Because who cares what the y is? The x will always be 6. Likewise, when you have a horizontal line, like in C, what never changes? The y. So we have y equals, well, what is y? Oh, it's 2. Okay, so in that way, when x's and y's are related, we can communicate that 3 ways: as a list, as a graph, as an equation. And you did that last year. Now, has Mr. Alexander, did Mr. Alexander talk to you about domain and range? Seeing no. All right, so this is, let's just write that this is not in curriculum. I wish I could spell it. So not on test. How do you spell curriculum? What am I missing? Oh, cur, right? Is there an R or an L missing? There's a double something, right? It's a double R? Okay, thank you. Okay, let me fix that. So why do I show you something that's not in the curriculum? Because next year, when you learn how to do domain and range and you've already seen it, your brain will be like, oh, cool, I've seen this before. As opposed to like, oh my God. Like, you're going to see there's a lot of new stuff in the functions course. So if you have seen something, played a bit with it, you will be in much better shape. So what is domain and range? So domain is just a list or a set of the first elements, i.e. the x values. So when we have a relation, we can split up the x's and y's, and all the x's are called the domain. And then the second elements, i.e. the y values, are the range. So I want to show you some notation about how to write the domain and range. So all we're doing is we're taking the x and y, we're splitting it. Okay? So let's turn the page and let's practice. So for relation A, I want to know what's the domain and range. Now, the domain and range is still a set. So what type of bracket will I use if it's still a set? I'm going to use a curly bracket. Okay? And I'm just going to make a list. So in relation 1, I've got 2, 4, 6, 8. Those are my x's. So we list them off. Okay, my x's are 2, 4, 6, 8. Close bracket. That's my set. What's the range? Well, let's look at what the y's are. 3, 5, 7, 9. Okay. Let's do one more. Let's do relation B. So in relation B, the x value is always 6. So watch this. That's the domain. Okay, we don't have to write 6 multiple times. The range is going to be all those points. So we got -2, -1, 0, 3. So it's a set, -2, -1, 0, and 3. Okay, so we're just saying, hey, we can split up the x's and y and still make them a set of their own. All right, so now let's jump to the next definition, which is a function. Now, a function is also a set of ordered pairs. Here is the really important piece. Every x value has only one possible y. I want to highlight that pink. Every x value can only have one y value. So this is like a specific type of relation. So it's one of those things where, like, you've got relations. You can just drop it here. And within relations, there's a small subset called functions, right? Because relations are just x's and y's. But a function, every x can only have one y. So you can't have x showing up twice. Yes?
Does that mean like a vertical line then wouldn't be a function?
That's it. Right? This vertical line, how many values of y does the x have? 1, 2, 3, 4. Not a function. So let's look at these examples and let's see if they are a function or not. So we're looking for repeating x's. In example M, are there any repeating x's? No. So yes, it's a function since no repeating x's. Second one, function or not a function? Not a function. Not a function. X's have multiple y's. And in the next one, function or not function? Oh no, I see a lot of repeating x's. So what are we going to say? Not a function for the same reason. Yeah.
What about a horizontal line?
Okay.
Horizontal line a function?
Well, you tell me, are the x's repeating?
Well, no, but if the y's are repeating,
That's okay.
the y, okay, so
Now let's look at it visually to understand it. So there's another way that we can tell if something is a function or not. On a graph, we use the good old VLT, not to be mistaken with the BLT, which I love. The VLT is not as tasty. It is called the vertical line test. So when we do a vertical line test, we draw vertical lines, believe it or not, through a graph, right? So here we have a linear function, and I'm drawing vertical lines, and I'm checking, do any of these lines touch the graph twice? They don't. Well, what if we have a sideways parabola like this? Let's draw some vertical lines. Doesn't touch parabola, doesn't touch parabola. Watch, touches it once, touches it once, watch, 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 touches it a second time. Dangers. So is the sideways parabola a function? No, not function. How about this nice looking 7? Let's draw some vertical lines. Go ahead. As you draw these vertical lines, will one of the lines touch the 7 twice? Failed. And so what we can say is this failed the vertical line test. It's not a function because it failed the VLT. The first one is a function. It passed the VLT. But the next two failed. So when we're checking if something is a function or not a function, if you have a graph, you get to do the VLT. If you don't have a graph, if you have a list, okay, you're going to need to check if the x-axis, if the x points repeat. Okay? So this is the first part of the lesson. You don't need to do domain and range. I will be bringing it up so that you kind of get more and more comfortable with it, but you don't need to know it. Okay? And so for your homework, there are a few pieces for function, like that first part of homework on page 197. That's where you're checking if something is a function or a relation. Okay? You've got 5 minutes. Why don't you start doing some of the homework for that? They might even call us a bit later, so we'll see. All right, Hugo and Caleb, I'm giving you like 3 more minutes. Is that cool? Yeah, it does. On the front page, if you look on the table of contents, like look at the first page of the worksheet. It says 1 ACE 7. Yeah, and yeah. Great. Thank you.